This video goes over the equations versus expressions worksheet for either Math 95 or Math 97, and we are going to look at the third column, first row first, because I've already done a couple of the initial ones in the intro video with directions. So I'm just going to put the X for expression and the O for equation in the corner rather than trying to circle the answer like it says in the directions. So if I look at this box, 3 minus x equals 9, I would say, first of all, that is an equation because it has things on both sides of the equation. So now I'm going to go ahead and solve it. I'm going to subtract 3 from both sides. Now be careful here. Make sure you bring down that subtract. That's actually, if you want to write it like this, plus negative x, that might be helpful in this case to not forget that. Negative x equals 6. Now I'm not quite done because I need to have a positive x. So I'm going to divide both sides by negative 1, which is actually the coefficient here if you want to just kind of sketch that in. And then we would write it as x equals negative 6 for our final answer. Okay, moving right along to the next row, we have 3x times quantity, x minus 2, subtract 2x. There is no equal sign here. There's nothing on either side of an equal sign indicating an equation, so that would be an expression. And so now we're going to simplify that. We are going to distribute, get rid of our grouping symbols or just kind of deal with them. A lot of times we want to look first, is there anything inside those parentheses we can combine and whatnot, but there isn't. So I'm going to need to distribute and free that up. So then I have 3x and then 3 subtract 2. That's kind of like the same as, or 3 times subtract 2 is kind of an awkward thing. So you might write it as add the negative there. So inside the parentheses, I've just changed that to be x plus negative 2 so that it's more clear. So then I would have 3 times negative 2 is going to be negative 6. And then again, this is really subtract 2x is the same as adding negative x. You can just bring it down. So whatever your preference is, if that tool works for you, great. If not, don't use it. So here I have 3x minus 2x is going to give me just a plain x. And then bring down the plus negative 6. I would just write it as minus 6 to keep it nice and streamlined. And that would be my answer. Now, one thing I should do here, instead of just writing underneath, I should say this expression here, this 3 times quantity x minus 2x is actually equal to this expression 3x plus negative 6 minus 2x is equal to x minus 6. Now that doesn't suddenly make it an equation. It's still an expression in the long run, but just be careful when you're writing that. You should make your statement that this is equal to that and so on and so forth, but track what you're doing so you don't go back and look at it. Sometimes people look at it and they write crossways and then they start suddenly solving for that, which is not an equation to begin with. That's why we're doing this exercise. So you're not going to get an answer, just a number answer, unless everything like cancels out and you're just left with something, or sometimes you're plugging in values and evaluating. Now this next one, 5x plus 3 minus 7, that's an expression. I'm just going to go through some of these real quick. So that would be equal to 5x minus 4. Done with that. Don't try to solve it. Now this fraction one, this is the one people are kind of having struggles with and have asked about. So I'm going to actually make this a bit bigger. And kind of might need some room on the edge. So this is an equation. So I'm going to put my circle there for my box, my tic-tac-toe game. And then what I want to look at here is I could just get a common denominator. I could combine like terms. I could go that route. That wouldn't be too challenging here with this one. However, I do want to show you a different technique of clearing the denominator that works really nicely instead of getting a common denominator. With the one below, you can see the difference. There's nothing to balance. There's no equal sign. It's not an expression. I mean, not, sorry, an equation. It is an expression. So we are going to need to find a common denominator, and I'll show you how to work with that one after. So for this, if I multiply anything, like if I had something that said x equals 3, for instance, if I multiplied that whole thing, if I doubled everything, or doubled both sides, you could even say, but even just doubling that whole thing, that would be 2x equals 6. Do you agree with that? So what I'm doing is making a multiple here of this. So I'm multiplying this entire equation by whatever all these denominators will divide into. So I'm looking for the lowest common multiple there. So you could think of it as multiplying both sides by that. Okay, that would also work over here too. If I multiply both sides by 2, I would still get 2x equals 6. And I would have an equivalent statement. It kind of looks like a little, I want to be multiplying here, not doing an exponent. So this little page number's in the way. Okay, so just want to make sure you know that's just a little side note over there. So if I do the same thing here and I multiply both sides by, I'm going to choose 15 because I know 5 will divide into 15 and so will 3. So I want to do that to both sides, or you could think of it as making a multiple of this equation. But I can balance. So here I want to distribute to every term. Okay, so I need to multiply every term by that. So I'm going to write out 15 times 2/5 x. Now you could do this a little more streamlined if you want. Then minus 15 times 1/3 plus 15 times x over 5 equals 15 times 2/3. Now notice these are all over 1. I'm just multiplying but the numerators by 15. So I'm not getting a common denominator in combining like terms and things. I'm clearing the denominator, different technique. So now when I go ahead and simplify, I have 5 into 5 is 1, 5 into 15 is 3. That leaves me with 3 times 2 times x is 6x. Then over here I have 3 into 3 is 1, 3 into 15 is 5. So then I have a 5 there, 5 times 1. Let's remember my denominator should go away. They should go to 1. 5 into 5 is 1, 5 into 15 is 3. So then I'm going to have a plus 3x there. Bring down my equals, so it's an equation. Simplify here, 3 into 3 is 1, 3 into 15 is 5. So I'm just dividing by 3 over 3 for that. And then that leaves me with 10. Now I have a much cleaner equation to work with. I have 6x plus 3x is going to give me 9x. Bring over the minus 5 equals 10. Then add 5 to both sides. Okay, and then I end up getting 9x equals 15. Divide both sides by 9. And then I get x equals, and I have to reduce, right? So I'm going to divide by 3 over 3 because that's my greatest common factor there. So I would have x equals 5/3 for that one. So that's kind of a long one. So hopefully those steps are helping you learn how to do that process of clearing the denominator. Now for this other fraction that's an expression right underneath, I'm going to skip the other ones right now and just jump over to that. The thing that we could do here, because we cannot clear the denominator, we can actually just rearrange this a little. We can use our commutative property and rewrite this so kind of clump together. You actually don't need to rewrite it, but just so you know that you can see it a little more clearly. 2/5 x and then plus x over 5 would be like 1/5 x, because that's like a 1, and then it's just not shown there. And then we have minus 1/3 and then minus 2/3 with no x there. So I can just go ahead and figure out these two first. So 2/5 x plus 1/5 x would give me 3/5 x. And then minus 1/3 minus 2/3 is going to give me minus 3/3. And then that is actually going to be equivalent to 1, right? So because I'm going to divide top and bottom by 3, or just know anything over itself is 1. So that would be my answer there. This x is just noting it's an expression. I'm going to just move that down a little there so it's out of the way and it doesn't look like it's part of the problem. So the next one, I'm going to jump back over to the left on the third row. 3 times quantity x minus 2 equals 2x. That is an equation. So we're going to go ahead and solve, and I'm going to distribute 3x minus 6 equals 2x. And then I want to subtract 3x from both sides. I get negative 6 equals negative x. And then I can just change each sign to its opposite, but really what I'm doing is dividing through by a -1. So that gives me x equals 6. And I want my x on the left-hand side. The one in the middle of the last row, be careful here. This is not 4x times quantity 2x minus 4. It's 4x minus quantity 2x minus 4. So a way to rewrite this would be rewriting it as 4x plus -1 times quantity 2x minus 4, or even plus -4 if we're going that route, equals 8. Now you don't need to do that, but it makes it real clear what you're looking at. You can just, distribute that negative through, but track what you're doing. So the 4x comes down. We would have plus -1 times 2x is going to give me a -2x. -1 plus or times -4 is going to be a +4, and then equals 8. So now I have 4x minus 2x is just 2x. Subtract 4 from both sides, and I am going to get 2x equals 4. Divide both sides by 2. I get x equals 2. And this was an equation, so we have our circle. Okay, so the discussion points are, do the answers to equations look any different than the answers to expressions? Well, yeah, my answer would be the equations would have an x equals a number, so you have a variable equal to a number. The expressions are, you're left with an expression. You don't have an x equal to that. It's just for instance, this one, 3/5 x minus 1. Okay. So I hope that helped. Let me know if you need more work with fractions. Have a great day.